All right. Thank you, Allison. Appreciate it. Excited to be here. My name is Ryan. I'm a board certified health coach. I have a master's in neuroscience. I'm just finishing up my PhD in health and human performance. My background is exercise science, and I am a medical exercise specialist. So I get bored easily. I like to pursue a lot of certifications. But most importantly, I like to be of service to older adults looking to prevent cognitive decline, prevent dementia, and many of those I work with already have some kind of cognitive decline or cognitive concerns. And it's helping to slow cognitive decline or maintain brain health. I work at the Pacific Neuroscience Institute Foundation here in Santa Monica, part of the Pacific Neuroscience Institute. We've had the pleasure of referring many of our patients and clients to Cognitive Care Solutions, and I'm happy to be here today to talk to you about exercise and brain health. So it's first helpful to get a better context as to when we're talking about brain health, what do we really mean? Brain health can mean a lot of things. It can mean the brain volume, the size of certain brain regions, the way your brain functions. It can also usually mean cognition. Cognition, there's mental functions, things like attention, memory, processing speed, organization, time management, things of that regard. So the first thing to note is if we look at the top of this chart, and I will have some annotation tools, a little laser pointer, hopefully you can see that red laser pointer there, that most people normally, hopefully, are at the green line. The green line shows a slight cognitive decline over time, but you'll see it's not significant in terms of steepness, but it's good to know that there are normal things that change with age. I think the biggest challenge is what's normal and what's not normal. And I'll say right now, regardless of whatever you hear in this presentation or whatever you've heard elsewhere, it's important to go to a neurologist to get an evaluation or cognitive evaluation of any kind from an allied healthcare professional in the brain health field, whether it's very brief, conversational, more extensive like neuropsych testing, just to see where things are at. And everyone gets a colonoscopy to get their risk checked, but no one does a cognoscopy as much as they should. A cognoscopy is a made-up term by Dr. Dale Bredesen to infer getting your brain health checked out. So if you're over the age of 60 or 65, I suggest, regardless of how you feel, getting your brain health checked out is important, even if it's just to see your risk factor and make sure that you're normal. With that said, there are some normal changes to cognition, like processing speed, certain types of complex attention, certain aspects of short-term memory that can decline slightly with age. Some people are on this light blue line, where they're what's called the preclinical stage of brain aging or subjective cognitive decline. This is the area where you notice that something is not as normal as you feel it should be. And yes, this could be anxiety, but it could also be actual concern about your memory or your cognition, your processing speed. You just don't feel something's right, but you can kind of mask it from other people. And it's a stage where you know, but the doctor, no one else knows. In this stage is where you should definitely be going to see a doctor because this is early. And you can see there's not much of a delta between the green and the blue line, but it's important to get that evaluated early so we can modify this trajectory, hopefully. Then there's mild cognitive impairment, also called MCI, and this is cognitive change of a concern that's to an individual or family member, slightly more significant cognitive impairment in one or more domains of cognition. So this could be slightly worse than normal memory, worse than normal executive function, things like that. And one of the reasons a lot of people don't do anything about it is because they say, well, I have preserved activities of daily living. I can still bathe myself, feed myself, toilet myself. Maybe they're still driving, which is a controversial area. But really, this is a diagnosable condition that you can see as a middle stage between normal or preclinical and dementia. And then dementia, which everyone's heard about, is cognitive impairment that's severe enough to interfere with those everyday abilities. There's mild, moderate, severe, moderately severe, and severe. And there's different types. The most common one is Alzheimer's dementia, but there's Lewy body dementia, vascular dementia, and mixed dementias. So your goal is to know where you are on this chart. I can't tell you because I don't know you and I'm not your doctor, but you want to know where you are on this chart. Hopefully we're closer to this side. But even if you are at this MCI stage or even early or mild dementia stage, our goal is to try to extend out these trajectories to get you the greatest quality of life that we can. There's also something called cognitive reserve, which is what actually mediates this trajectory of cognitive decline. And cognitive reserve is kind of a metaphor for your mental gas tank. So the higher your cognitive reserve, the longer we avoid neuropathologies, including dementia. And so research has started to show that there's a lot of things that contribute to cognitive reserve. Some things include managing a healthy heart, managing cholesterol, blood pressure. Untreated hearing loss is a big risk factor for dementia, untreated vision loss, having things like traumatic brain injuries in your past, having chronic stress or an undiagnosed or untreated mental health condition. These are all things that can reduce your cognitive reserve. But then there's things that increase cognitive reserve. And these are your 6 lifestyle factors that actually increase cognitive reserve. Exercise and physical activity, which we're diving deep into today, sleep, diet, stress management, cognitive stimulation and brain training, and social support. So the one we're diving into today is exercise and physical activity. Now, raise your hand if you think that exercise is good for your brain. I know I can't see everyone, but yeah, okay. So it's not new, right? It's not new that we just found, it's like, oh my gosh, I just found out exercise is good for my brain. If you did, congratulations, welcome to the club. If you do know that exercise is good for the brain, that's great, but how? How is it good for the brain? I'm going to show you multiple perspectives on this, and we're going to have a nice, big, complete picture of all the ways exercise could benefit the brain. The first one is the stimulus. That's the exercise. When we get our heart rate up, we can go through a process, what's called angiogenesis. Angiogenesis is the creation of new blood vessels in your brain. And this happens because when our heart rate increases, we also increase what's called cerebral blood flow, or CBF. You have about 400 miles worth of vasculature in your brain. That's a lot. Some of those are side roads, some of those are highways, but we need to take care of those roads. And one of the ways we do that is through increasing blood flow. When we do this, we undergo this process of angiogenesis, where you can see these blood vessels are in the process of connecting and becoming more connected. These are capillaries in the brain. That's part of that mileage, that 400 miles worth of vasculature in your brain. And when we undergo exercise over several months, we increase the density of our capillaries. Our brain is more responsive to metabolic demands, and the connectivity, that 400 miles worth of vasculature, is better connected. What that leads to, this is called a neurovascular unit. So this red part is a blood vessel, and this part here is a neuron. That's a brain cell. You have billions of brain cells. So this is showing you a model of what might be happening when we get more blood flow. We create more blood to this area, to this neuron, to this junction, and that blood has oxygen and nutrients. That leads to protecting these neurons. It leads to improving learning and memory, and it promotes growth of these areas as well. There's also these things called growth factors. I know this looks like a complicated slide, but I'll walk you through it. In the middle, you'll see that neurovascular unit we just talked about. When we exercise, there's these things called growth factors. These are hormones, proteins, they're molecules that are released either in the brain, they're mobilized, or they're released from the heart and the muscle, and they cross the blood-brain barrier and tell this neurovascular unit to grow, survive, proliferate, continue to work well. One of these is called brain-derived neurotrophic factor. It's also called BDNF. Some people have called it miracle grow for the brain. I wouldn't go that far, but it seems to be a precursor that helps with improvements in memory, learning, blood flow, and it helps to improve the size and or function of an area of your brain called the hippocampus, which is a memory region of your brain. There's also other growth factors like nerve growth factor, vascular endothelial growth factor, which helps with that angiogenesis we just talked about, and something called insulin-like growth factor 1, or IGF-1. There's also another one not shown here called irisin. And IGF-1 and irisin are usually more so just released when we do resistance training. So we get BDNF and VEGF from aerobic exercise, but we get irisin and IGF-1 from resistance training. So and we get nerve growth factor and lactate from both. But this is why it's going to be important to have more than one type of exercise, so we can have different concentrations of all these different growth factors. Now I'm going to show you what happens when you exercise once. This is called the acute benefits of exercise. So let's say we exercise for 20 minutes or 30 minutes on an exercise bike, and then we stop. For up to 15 minutes after stopping exercise, we have an activation of our prefrontal cortex. And for up to 2 hours, we're a little sharper. What's happening in between that in the background is we're releasing all these growth factors, GABA, lactate, glutamate. These are also neurotransmitters, norepinephrine, dopamine, cortisol, and serotonin. You've probably heard of these. And there's that BDNF we just talked about. We also increase our brain waves, delta, theta, alpha, beta, all of it gets excited. And for up to 3 hours, we have improved stress reduction. And for up to 24 hours, even if you're exercising as little as 5 or 10 minutes, for up to 24 hours, our mood is better. Now, that's only after one bout of exercise. If we want these things to be more significant, more chronic, meaning they last longer, they're more significant in their benefits, we have to do this over weeks and months. Now, let's talk about what happens if you are exercising consistently for 3 months or more. At the micro level, which is an area where you need maybe a microscope or a lab test, sometimes this is in animal studies, sometimes this is in human studies that we learn these things. It turns out it's really difficult to get an older adult to run on a treadmill, immediately kill them, slice open their brain and examine it. So I know that's morbid, but that's why we don't know everything in humans of what's happening in the brain, but we do that with rats. So we've learned a lot from rat studies and exercise studies. So some of this will depend on who we study it in, but by and large, we know that in the micro level, we have these growth factors. We have this expression of more blood flow, more neurovasculature, more angiogenesis. Neurons will connect, they'll grow. In certain areas of the brain, like the hippocampus, we grow more neurons, a process called neurogenesis. And so we just have a stronger, more vascular and neuronal network due to all these things. Now, at the macro level, this is where if we held our brain in our hands, I know we don't think about that too often, we could either see that it increases in size, either in one particular area or the gray matter of the brain as a whole, and or it's improving in function. So your brain's an electrical organ. So electricity is how the brain functions. But in order to produce that electricity, we need blood flow. And so it makes sense if we have more blood flow, we have more brain activity. And so research has shown that if I exercise as little as maybe 4 weeks, 3 to 4 weeks, there's more efficient brain activity. If I'm exercising for 3 to 6 months, I might see an increase in the size of the brain or certain structures in the brain like the hippocampus. That's at the macro level. But the behavioral level, this is where we're going to feel improvements in our cognition and our mood. So when we exercise, we typically feel better, we feel sharper. We saw that from the previous chart of what happens when we exercise once. But if we're exercising for multiple weeks and multiple months, we're actually going to have usually more significant improvements in cognition or mood. So exercise does all of this. It acts on all these levels, which is something that medications cannot do, and which is why it's called exercise is a poly pill. It's really a metaphor that it acts on so many different levels. I'm not even talking about blood sugar, inflammation, or hormones. It's also helping those things. It helps with sleep. It helps with body composition. It helps to prevent falls. So this is just showing you what happens at the brain level. It's not showing you what's happening everywhere else too. Also, I think it's worth talking about mental health. Exercise has been shown to improve energy, improve confidence, improve your self-esteem, improve your sleep, improve your mood, and reduce stress. So let's talk about what certain types of exercise might do to different parts of the brain. Shown in red here, that's the hippocampus. That's the area of your brain responsible for learning and memory. It's an area of your brain that everyone wants to improve and learn about and take care of. It's located deep inside the temporal lobes, which are right underneath your ears, and it's in the middle of the brain. So the temporal lobes are known to be responsible for language, spatial navigation, as well as memory. And the hippocampus specifically is responsible for memory and learning. It also does some other things, but we're keeping it simple. When we do aerobic exercise for several weeks and months, this area of the brain, the hippocampus, has been shown to actually improve in size, even if you have a cognitive impairment. It also does respond to resistance training. So when we do resistance training, especially if that resistance training or strength training gets our heart rate up, that will also help certain parts of the hippocampus. Now, just because you start doing aerobic exercise doesn't guarantee that you're going to improve the structure of this. And the best way to know where your hippocampus is at is to get a volumetric MRI without contrast of your brain. Now, you should also do with contrast or whatever your doctor directs, But that's how we can actually see the size of your brain as a whole, as well as certain structures, including the hippocampus. And that's what allows us to know if it's, are we normal for our age and gender, above average, below average, or average. But research shows older adults who are healthy, older adults with cognitive impairment, and older adults with mild dementia, they can actually improve the size of their hippocampus after exercise interventions, depending on the duration, the intensity, and so on and so forth. And of course, when we improve function or structure, and I'll say that it's okay if you don't increase the size, you can still improve memory performance. And also with aging, there are some normal rates of decline of these brain regions. So even if we don't increase the size of the hippocampus, but you prevent it or you slow down its decline or shrinkage, that's also a big win. Or regardless of the size of the brain, we improve the function and that improves our cognition. That's also a big win. So that's something that aerobic exercise as well as resistance training can do. Then there's something called the frontal lobe. The frontal lobe is right behind your forehead here. It's the full frontal third of your brain shown in red. When we do resistance training or strength training, and I don't mean these light 2-pound pink dumbbells, that's not what I'm talking about. I'm talking about resistance training where you can't do more than 12 to 15 repetitions because of the weight. And you're doing that 2 or 3 repetitions for most major muscle groups about 2 to 3 times a week. We can go over those details a little bit more. But when we do this type of resistance training over periods of weeks and months, we actually see structural and functional improvements in the frontal lobe. There's lower white matter atrophy. So there's the gray matter and the white matter. And when we exercise, those things don't shrink as fast as they would if we didn't do exercise. And we improve our executive functions. That's the CEO of the brain. It coordinates other skills. It's complex attention, impulse control, short-term memory. So that's just from resistance training. So we saw so far the hippocampus can be improved with aerobic exercise. The frontal lobe can be improved with resistance training. And, resistance training can improve the hippocampus. And of course, exercise has an effect on the frontal lobe. So it's not a pure, like this equals that one and not the other one. They do have some overlaps, but it's good to know these have some differential brain effects. Then there's something called motor fitness. These are things like racket sports, dance, martial arts, Tai Chi, yoga. These things affect the cerebellum, which is in green, and the basal ganglia, which is in pink. And you might have heard of the basal ganglia because this is the area of the brain affected in Parkinson's disease. It produces dopamine. And when we do motor fitness, which things that require coordination and learning and skills and things like that, and complex movements, research has shown we can either increase the activity of these areas and in some cases improve the size. And when we learn a new skill, that's also cognitively demanding. We have to pay attention. And research shows that can also lead to cognitive improvements. And again, this is sports, dance, martial arts, from ping pong, which is my favorite, to Tai Chi. So this is not a perfect slide. Don't try to read everything from this slide. This is kind of a conceptual theory that if we're doing a bunch of different activities, we're kind of having what's called a whole brain exercise program. Now, it's not these specific activities, it's not baseball, but there's different activities that require neuromotor coordination, recognizing objects, coordinating movements, aerobic demand, resistance training, skill learning, vision, all these different things. And all you need to know is that when we're doing multiple things, theoretically, we're acting on different brain networks and brain regions. And I don't know about you, but for me, I want to cover my bases. So in the next few slides, I'm going to teach you how to do that practically. Before we do that, I do want to talk a little bit more about open skills versus closed skills. We all know what a skill is. A skill is something we learn. Most exercise as we know it is a closed skill. That means it's stable, predictable. We know when the movement begins and ends, and I know what to do and when. So I know in a bicep curl, I curl it up, I curl it down. If I'm on a machine, I push and it comes down. Nothing crazy is happening. It's not like there's a sport where I'm competing in exercise machines and the exercise machine is changing around me and I'm not sure what's happening. We always know what's happening when we're on a machine or we're doing walking or we're swimming. These are all closed skills. These are good for you. Do not stop doing these things. These are good for you. But most people, this is all they're doing. Then there's something called open skills. The environment's constantly changing. Movements have to be continually adapted. It's predominantly externally paced by another person, if it's a dance or a martial art, or an object like a ball in a racket sport. And what's interesting about these open skills, you can't play them with your eyes closed, and you really have to pay attention. You can't be watching the news while you play tennis but you can do that on an exercise bike. And so what's interesting is, once again, both open skills and closed skills are important for brain health, but open skills seem to enhance certain cognitive functions more than closed skills. So it's also important to have physical activities that require you to pay attention and use your brain as you're going through the physical activity. Of course, in the picture here, this is tennis. It could be table tennis. It could be pickleball. It could be dance. It could be a whole variety of things. Now, if exercise is medicine, what is the prescription? We're going to go over that now. You might have heard this before. For substantial health benefits, adults should do at least 150 minutes to 300 minutes. In plain English, that's 2.5 hours to 5 hours a week of moderate intensity or greater. Now, this is the thing. When I talk to people about 150 minutes, the first thing I want to see is, okay, let's see how many times a week you exercise. If you say you exercise 5 times a week, and then you say you exercise for 30 minutes each time, 5 times 30 is 150 minutes. So conceptually, you'd be hitting that. But then if I say, what are you doing? And you say, well, I'm walking 5 times a week for 30 minutes. I say, well, is that a low intensity or a moderate intensity? And many people say, oh, it's actually a low intensity. And so if I say, well, if we just get that 30 minutes to a moderate intensity, which on a scale of 1 to 10, 10 being the hardest, is about a 5, 6, maybe up to an 8. We're doing hills, maybe we're on a treadmill, we're increasing the pace without increasing fall risk. We do it on a bike instead, and we get that up to a moderate intensity. Now you're hitting the minimum guidelines. And the minimum guidelines are inclusive of brain health benefits. So if you're hitting 150 minutes a week of moderate intensity or greater exercise, you're going to get multiple functional, structural, cognitive, and mood-based brain health benefits. There also seems to be additional benefits and better dementia prevention capabilities of doing one or more than one type of exercise. This is called a multi-domain exercise program. So instead of just doing aerobic, for some reason, a lot of people believe aerobic is the best type of exercise for the brain. That's not necessarily true, as we've learned. There's actually unique and shared benefits across different types. And when we do aerobic and resistance or resistance in a racket sport, that's going to be better for your brain than just doing one type of exercise only. We also see these additional benefits for adding in motor training, like Tai Chi, like dance, like racket sports. And the dose response is, even if you have a cognitive impairment or you're healthy, it takes about 52 hours of exercise to see significant improvements in cognition. You will see improvements in cognition prior to that, but significant improvements in cognition. Now, what does that mean for you? That's going to be different for everybody, but it takes about 52 hours. Now, 52 hours over what period of time? Well, if you're exercising 3 days a week for, let's say, 30 to 60 minutes, it might take you 8 to 12 months. If you're exercising every day, you might get to that in as little as 3 months. But when you accumulate 52 hours of exercise, you do not stop. That's just the minimum amount of time across a big systematic review to see improvements in executive functioning and processing speed. And it didn't matter what type you did, really. We just need to accumulate hours of exercise. So let's go over the 3 types of exercise. In nutrition, we have carbs, fats, and proteins. And you know, usually, at least reasonably, how much of each one to do. Our carbs, fats, and proteins are aerobic, strength, and motor, or what we also call skill training. We're going to go over how to put these together for you. Here are the variables. These are called acute variables. When I evaluate an exercise program for somebody and I'm trying to help them achieve better brain health through exercise, I'm looking at these top 3 things. Frequency is how many days a week are you doing it? 2 days a week, 3 days a week, 5 days a week? What's the duration? Is it 10 minutes, 30 minutes, 60 minutes? And then what's the intensity? On a scale of 1 to 10, 1 to 4 being low, 5 to 8 being moderate, and 8.5 or greater being high intensity. I want to know the average of your intensity. But I also want to know, is there a skill that you're learning in your exercise program? Are you doing things that are relatively new, whether it's a completely new activity like a dance class you've never taken? Or if you're playing tennis, you're playing against someone you haven't played before. And then what's the environment? Is the environment conducive to something you enjoy? Is it social? Is it interesting? Is it indoor? Is it outdoor? This is more personalization based on your preferences, but I like to know what kind of environment you're doing this in. And you might ask, what's the best environment to do an exercise? And I say there isn't one. It depends on which one enables you to get the most out of your exercise program and do it more frequently with enjoyment. For some people, that's online. They won't be caught dead in a group class. I'm one of those people. I hate group classes. But then there's other people that group classes are everything to them, and that's fine. Just like if we all went to a restaurant, we're all going to pick something different on the menu. Exercise is no different. So this is your checklist. This is probably the most important piece from this presentation, that if you're going to write something down or take a mental snapshot of, this is it. This is your brain health exercise checklist that you want to know. If you cover these bases, at least from an exercise perspective, you're going to have a much brain healthier exercise program, regardless of where you're at. So the first thing is you need a minimum of 150 minutes or 2.5 hours a week. If you're not hitting that, the main variable we could adjust is either duration or frequency. So if you're exercising twice a week for 60 minutes, you just need to add one more day a week and you're at the 150, assuming it's a moderate intensity. If you're exercising 5 days a week for 30 minutes, but it's at a low intensity, well, we could easily modify the intensity. Well, I hope it's easy. And then we get there. Maybe you're doing 5 times a week for 30 minutes at a moderate intensity or greater, but you're only doing aerobic. Well, maybe we need to switch out a couple of those days for resistance training. Or maybe we can take part in a Zumba class or a dance class, and we're doing neuromotor exercise, and it's also aerobic. Well, you're hitting 2 birds with 1 stone. That counts. And when we do things like Tai Chi or yoga, typically it'll be a low to moderate intensity. But Tai Chi and certain types of dance and yoga, they don't always get our heart rate up. Sometimes they do. But even if they're low, they still have a benefit on cognition. Because remember, those open skills. And there's benefits to moderate intensity. And we shouldn't be afraid of it. There's benefits to high intensity if you're cleared by your doctor or cardiologist to do that. We also want to incorporate some kind of open skill where we're learning and paying attention and making sure that our exercise program has some cognitive demands. Sometimes that can be as easy as kind of divorcing that sheet of paper you got from your physical therapist 10 years ago, hiring a therapist and getting a new program so that your brain and body adapts to something new. Sometimes that's taking a new class. Sometimes that's taking a new walking route. Sometimes it's playing against a new person if it's tennis or table tennis. And then, of course, we want to design for enjoyment and behavior change. A lot of people say the best type of exercise is the one that you do. I agree. The best type of exercise is the one you enjoy. I do agree. But I don't think you have to feel like it's Disneyland every time you exercise to get benefits. You do not have to be in love with it to have it as part of your everyday routine. If you hate resistance training and you hate weights, it's still important to do them. Just because you don't enjoy them doesn't mean we shouldn't do them. It's kind of like vegetables. If you hate broccoli, there's ways to get the nutrients from that substrate in a way that is enjoyable for you. Of course, I like to negotiate with people, and I like to figure out what works best for them. Sometimes they won't lift weights on their own, but they will work with a trainer. They won't work out on their own at all, but they'll attend a class. So everyone's going to be different based on your preferences and what you enjoy. And a lot of the times we might have what's called negative exercise experiences. You tried to lift weights in the past with a trainer and you got hurt. These episodes are reasonable. And I think we just have to give it a second chance because there's so many ways in which to modify these programs in order to make them something that's personalized and enjoyable for you, that we can do that. I'm just going to give you one example of an exercise program here that checks off all of those boxes so you can see how this could be possible. Let's say Monday and Friday, I'm going to go to the gym or work out at home in my apartment complex gym, whatever. 30 minutes, I'm going to ride the bike and get my heart rate up where it's maybe a 6 out of 10, let's say. And then I'm going to lift weights, also 6 out of 10. That's 60 minutes total. You just did your cardio and your weights. You do that Monday and Friday. You've checked off your weights. You've checked off your aerobic. On Wednesday, you're going to do Zumba. Zumba will do 2 things. That's motor training, and it's going to be aerobic. If I do that for 60 minutes, if I'm learning a movement, maybe a 4 out of 10, but then when we're putting everything together, I'm out of breath, maybe it's a 7 out of 10. That also counts for your aerobic minutes. And then Saturday, it doesn't count towards the aerobic minutes, but walking. Walking is still good for your brain. It's still good to be physically active and get those steps in. So just 3 days a week, 60, 120, 180, that's 30 minutes over the 150. We're doing aerobic, we're doing neuromotor, and we're doing weights. So you can see it just 3 days a week, we could do that. Now, if you were more motivated, I'll explain this program. I know this looks complicated, but if you were more motivated, you want to exercise every day, and you are very determined, very motivated to do everything you can for your brain health, and you want to go in on that, then this is one type of program you could consider. This is just an example. I'm not suggesting this for you. I'm just giving it to you as a template. Monday, Wednesday, and Friday, I'm going to go to the gym. When I go to the gym, I'm going to do what's called a multi-component program. AT means aerobic exercise. I'll get on the bike for 20 minutes. RT means resistance training. So I'll do the exercise machines for 20 minutes. And then I'll do some balance exercises, either on my own or what a trainer or physical therapist showed me for 20 minutes. That's 60 minutes total at a moderate intensity. And I'm going to repeat that routine Monday, Wednesday, and Friday. Tuesdays and Saturdays, I'll do Tai Chi. Could be in a group or at home, online, whatever you like. And then Thursday and Sunday, I do dance. Now, it's okay if you just did Tai Chi once a week and dance once a week. Now that becomes a 5 times a week program. Or you just go to the gym twice a week instead of 3 times a week. So, of course, you can modify this. But this would be one example of how to go all in, get more minutes, more types of exercise, more variety. So I'm happy to pause here. This is my email in case you want to email me directly with any questions you have. At the Pacific Neuroscience Institute, we do offer brain health coaching services. If people are looking to personalize their program a little bit more, I'm happy to answer any questions about that. But I thought we'd take some time to answer any questions and do a little bit of group discussion around maybe specific questions around exercise that you have or just in general for the group. Appreciate all your time so far.